For 11th Science, the first topic is some basic concepts of chemistry. In this topic, we are to learn about the different laws, also the classification of the matter, mole concept, moles of gases, atomic number, atomic masses, molecular mass, formula masses, and the mole triangle. These concepts are most important for the preparation of the solutions, their concentrations, also the some amounts of the compounds are formed are depends upon these concepts. First part is a matter. This matter, we have to learn earlier that the matter occupies the space and has a mass. The matter has a space and mass. Matter can be further classified into pure substances and mixtures on the basis of chemical composition. These chemical compositions matter are classified into the two types, pure substances and the mixtures. The chart as shown in this figure, matter, pure substances and mixture. Mixture again classified into homogeneous and heterogeneous, while pure substances classified into the elements and compounds. These elements are again classified into the three types, and these three types, depending upon these three types, there are the periodic elements present in these three types are the metals, non-metals and metalloids. The elements. Elements means the pure substances which cannot be broken down into the simpler substances by ordinary chemical changes. In ordinary chemical changes or the ordinary chemical reactions, there is the substances are cannot be broken down into the simpler substances. Such as substances are called as elements. While the compounds are the pure substances which can be broken down into simpler substances by ordinary chemical changes. Means the compounds are easily converted into the simpler substances under ordinary chemical changes, while the chemical elements are cannot be broken down into the simpler substances. And this is a difference between elements and compounds. The next most important part is the properties of the matter and their measurements. The characteristics properties of matter can be classified into two categories, physical properties and second is the chemical properties. The physical properties are those which can be measured or observed: color, odor, melting point, boiling point, density, etc. These are the physical properties. In these physical properties, there is no changes in the chemical composition of the substances. There is only color, odor or melting point, boiling point, density. These quantities are changes, but not there is a chemical change are observed in their composition of the substances. While the chemical properties are the properties where the substances undergoes a chemical change and thereby exhibit change in the chemical composition of the substances. There is a chemical changes exhibit in the substances are called chemical properties. For example, the coal burn in air to produce the carbon dioxide. And second, magnesium wire burns in the air in the presence of oxygen to form the magnesium oxides. This is the chemical property. They can be converted into their chemical properties or the composition of the substances. Then this is called as a chemical properties. Then the measurement of the properties. In this measurement of the properties, many properties of the matter such as mass, length, area, pressure, volume, time, etc. are the quantitative in nature. Any quantitative measurement is expressed by a number followed by the units in which it is measured. Means this quantity, mass, length, area, pressure, volume, time, they are measured in a specific quantity or the specific units, because there is only one glass. What? There is a water in liter, in milliliter, and this liter, milliliter can be gives. There is a quantity, and this measurement is important for the chemical substances. Therefore, definition for the unit is the arbitrarily decided and universally accepted standards are called as units. Arbitrarily decided and universally accepted standards are called units. There are several systems in which units are expressed, such as CGS, centimeter, grams, second, FPS, foot, pound, second, MKS, meter, kilogram, seconds. And these are the three types of the system: CGS, FPS, MKS are used to determine the unit. And other systems are also present. The SI system. In 1960, the General Conference of the Weight and Measures proposed a revised metric system called International System of the Units, that is SI unit. In 1960, General Conference of the Weight and Measures gives a revised metric system, and this revised metric system is called International System of the Units or System International, also called as a SI unit. The metric system, which originated in the France late 18th century, was more convenient as it was based on the decimal system. The SI system has 7 base units as listed in the table, and these are the fundamental specific quantities. These are the fundamental specific quantities are also called as a fundamental particles, fundamental units. These are the fundamental scientific quantities. Other units like speed, volume, density, etc. can be derived from these quantities. Therefore, another definition is a derived units. The unit like speed, volume, density are determined by the fundamental specific quantities can be derived from these quantities are called as derived units. The SI unit for 7 fundamental quantities as listed below as shown in the table. This table shows that there is a basic physical quantity, symbol for the quantity, name of SI unit, symbol for SI unit. In this case, there are 7 fundamental quantities are length, mass, time, electrical current, thermodynamic temperature, amount of substance and luminous intensity. These are the 7 fundamental quantities can be measured in the General Conference weight and measures in the France. Symbol for length L, mass M, time T, electrical current I, thermodynamic temperature T, amount of substance N, and luminous intensity is I P. The name of the SI units are length meter, mass kilogram, time second, electric current ampere, temperature Kelvin, amount of substance is moles, and luminous intensity is candela. And last column shows that the symbol for SI units. And this chart is important as a fundamental units. Then the physical properties. In this physical properties, the first part is a mass and weight. The mass and weight, these are the two different quantities. The mass is inherent properties of the matter. The mass of the body does not vary as its position changes. This inherent means it does not be separated, just like these properties. Mass is inherent properties of the matter, and the mass of the body does not vary as its position changes. On the other hand, the weight of the body is a result of the mass and gravitational attraction. Means it is weight of the body, it changes with the position of the body from the earth particle, because this depends upon mass and gravitational attractions. The weight of the body varies because the gravitational attraction of earth or the body varies with the distance from the center of the earth. Gravitational force is affected on the weight of the substances, and this depends upon the distance from the center of the earth. Hence, mass of the body is more fundamental property than its weight. The basic unit for the mass in the SI system is kilogram. However, a fractional quantity gram is used as a weighing the small quantity of the chemicals in the laboratory. SI unit for the mass is a kilogram, but in laboratory there are the fractional quantities are measured in terms of the gas, in terms of the grams. Hence, in terms of the grams, it is defined as 1 kg equals to the 1000 gram, and this is equal to the 10 raised to 3 grams. And this relation gives the relationship between kilograms, grams and grams. And this is the first physical property, mass and weight of the substances. Second is the length. In chemistry, we come across the length file expressed in the properties such as the atomic radius, bond length, wavelength of the electromagnetic radiation, and so on. These quantities are very small, therefore the fractional units of the SI unit of the length are used for the examples. For example, nanometer, picometer, Here 1 nanometer equals to the 10 raised to minus 9 meter and 1 picometer equals to the 10 raised to minus 12 picometer. In this case, this quantity are very small. If there is a measurement of the radius, wavelength, bond length of the electromagnetic radiations and so on, there is a chemistry. This measurement of the lengths are used. The quantities are very small, therefore the fractional units of the SI units of the length are used, for example, nanometer, picometer, etc. Here 1 nanometer equals to the 10 raised to minus 9 meter and 1 picometer equals to the 10 raised to minus 12 meter. Then third physical property is volume. It is the amount of the space occupied by the three-dimensional object. It does not depend on the shape. For measurement of the volume of the liquids and the gases, a common unit is liter is used, which is not an SI unit. The amount of this space occupied by the three-dimensional object means the volume, and this volume does not depend upon the shape of that molecule or the shape of that containers. For the measurement, there is a volume of the liquids and the gases. A common unit is used as a liter, and this is not a SI unit. Therefore, the 1 liter equals to the 1 dm cube equals to the 1000 ml equals to the 1000 cm cube. ml and cm cube are the equals. Therefore, 1000 cm cube equals to the 3 times 10 into the centimeter of the volume. Therefore, the SI unit of the volume is expressed as meter cube or m cube. The different kinds of the glasswares are used to measure the volume of the liquids and the solutions. For example, graduated pipette, burette, pipette, measuring cylinder, volumetric flask, etc. And these are the measurement of the volume of liquids and the solutions. These apparatus, that is graduated pipette, cylinder, burette, pipette, volumetric flask, are used to prepare or measure the volumes of the liquids and solutions. A volumetric flask is used to prepare a known volume of a solution. Following figure shows that the apparatus used to laboratory for measuring the volumes of the liquids. This measurement of the volumes of the liquids are already explained in our 11th standard practicals. In case of the basic apparatus or introduction of the apparatus, the first and second experiment can be studied. And these are the some apparatus as shown in this following figure. The first is a measuring cylinder. Second, 25 ml pipette. Next is a 50 ml burette, and this is a volumetric flask. These are the volumetric glass apparatus to measure the volume of the liquids and solutions. Next one is density. Density means it is a characteristics property of the substances. It is determined in laboratory by measuring both the mass and volume of the sample. This density can be determined by measuring both the mass and the volume of the sample, and the density is calculated by dividing mass by volume. Therefore, density of the substance is its mass per unit volume. Mass per unit volume means the density, and this density is determined by dividing the mass by the volume. Therefore, SI unit for density equals to the SI unit of mass divided by SI unit of volume. Means mass is measured in kilogram and volume is meter cube. Therefore, kilogram per meter cube, it is a SI unit for density. And the CGS unit contains the CGS unit for the mass is gram and CGS unit for volume is ml. Therefore, grams per ml or grams ml inverse or grams per cm cube. And this is the CGS unit are used to measure the density. Then fifth physical property is the temperature, and this temperature is measured in degree Celsius or degree Fahrenheit or Kelvin. These are the three units are used to measure the temperature: degree Celsius, degree Fahrenheit and Kelvin. Here Kelvin is a SI unit for the temperature. Generally, the thermometer is Celsius scale are calibrated from 0 to 100 degrees Celsius, where these two temperatures can be respectively as a freezing point and the boiling point of the liquid water at the atmospheric pressures. And these are represented on the Fahrenheit scale by 32 Fahrenheit to the 212 Fahrenheit. And this 32 Fahrenheit or the 212 Fahrenheit is calculated by using the formulas. Temperature is measured in terms of hotness and coldness of the object. There are three common scales to measure the temperature, namely degree Celsius, degree Fahrenheit and Kelvin. Here K is a SI unit for the temperature, and the following figure shows that thermometers based on this scale. Generally, the thermometers with Celsius scale is calibrated from the 0 degree Celsius to the 100 degree Celsius, and this is measured at atmospheric pressures. There is an interconversion for this degree Celsius to the degree Fahrenheit and degree Fahrenheit to the Kelvin. There are two formulas are used. The first is a 0 degree Fahrenheit equals to the 9 by 5 degree Celsius plus 32. In this case, Fahrenheit and degree Celsius, these two quantities are related with each other, while the Kelvin scale related to the Celsius is Kelvin equals to the degree Celsius plus 273.15. By using this formula, we can convert there is a Kelvin to degree Celsius and second degree Celsius to the Fahrenheit and lastly Fahrenheit to the Kelvin. And this is the temperature dependent terms. There are three types of thermometers are used. First is a Kelvin scale. This is 0 to 273.15 Kelvin. Celsius scale 0 to 100 degrees Celsius. And in Fahrenheit there is a 32 to the 212 for the water. And these are the three types of the measurement of the temperature carried out by using these three units. Thank you. Up to this point, we can discuss these physical properties and some introduction part of some basic concepts of chemistry. These physical properties like weight, mass, temperature, length, density and volumes are most important for our measurements, as well as there are some chemical and physical changes that takes place by using these physical quantities. Thank you.